Hello, everybody. Doo-doo-doom. Hmm. Sunday at midday. Not a lot of people streaming, huh? Let's see. All of Software Game Development has 800 viewers. There's a guy watching Loonduk. Okay. Games. New game prototyping. Fire M Dev. Oh, I thought it was Fire VM. Never mind. Static code analyzer for ARM32. Okay. there is hello crypto code. Hello everybody. There is an alarming number of people that have an editor with a side panel, a sidebar with the agent running. There is an alarming number of those. Holy cow. Hmm. Maybe I too should people borg from from being a Twitch chat client to being an AI agent chat client, so that you can use Borg to chat with AI, your AI, I don't know, friend, coworker, lover. Eh, I'm actually surprised. I'm actually surprised that Twitch does has not introduced some kind of like um, AI chat bot that you get into your stream. If you have a stream that has less than 10 viewers, then you get, for I don't know, like half an hour or something like that, then you get the bot that joins and starts interacting. Problem is that that thing would consume computational power that Twitch doesn't have a ton of that to spare or to waste on small time streamers, obviously. So never mind. This is actually why they haven't done it yet. Otherwise, I'm fairly confident they would have. Hey, Neuroside. Hello. Also, I saw these on Lobsters. Automated equality checks in C++ with reflection, C++ 26. In C++, comparing two objects for equality is straightforward when there are simple types like integer or strings. But what about complex nested structures? You may have to implement the comparison operator manually for each class, which is error-prone and tedious. So without reflection, you have to do this manually. Instead, I wrote a small example that fully automates the process. You just had an operator overload, and you call deep equal. What does deep equal do? The trick is that C++26 allows you to query a type's members at compile time and iterate over them. The function meta non-static data members of, which gives us a list of members. So far, this is fine. So far, this is not particularly different than what you would do in Zig. So far, complete implementation is less than 100 lines of code, and it comes down to the following lines. Template 4. That smells like. Don't you feel the inline 4 smell? It smells like inline 4. But then, const per auto mem colon std define static array std meta non-static data members of. What t? Meta access context unchecked? If not, compare same. So recursive. A dot square bracket colon mem colon. What is this? Is this like weirdo syntax to basically? I was about to say compare the relative memories, but that's not exactly it, because this is recursing into this. So this must have type this, or it needs to coerce to this. Oh, this is mem. Okay, this is at field. Of course. This is at field. Holy shit, man. What the fuck is going on, man? Man, the things that they have to do to mimic a fraction of our power, huh? The is more or less the inverse of the reflection operator wonk wonk t. Think of it as going into a meta universe with what, and coming back into the standard C++ universe with what? What even is this explanation? Oh my god! Oh my god! Uh, it's I mean, I feel like it's telling that a given thing is underdeveloped when people don't even have like just a straightforward way of explaining it. I'm really starting to appreciate. I mean, I've known this for a while. It's not big news to me, but lately it's become very topical. This idea of you're not going to achieve a good implementation if you cannot achieve a good way of explaining it first. Like, you need to have understood the problem to a point where you can explain it in normal terms, with, or rather with precise terminology, in a non-convoluted way. If you can't, then it's guaranteed. It's pretty much guaranteed that your implementation doesn't know what it's doing, because you don't know what you're doing. Woo! What the heck? Also, why can't you just pass the type? Oh, right, because types cannot be variables, I guess. Sorry, values. You cannot pass around a type value. This is what makes that type a value. The wonk wonk prefix. Yeah, so that is the only way in which you can make a value out of a type, out of a generic type. Jesus, though. Oh, woof. That is brutal. That is rough. That is rough living, man. It's It's like when you saw those stories where yeah, these people who started living in this place for the first time, like up the mountains, they would have to walk 4 hours every day, 2 hours to go, 2 hours to come back, to get clean water. It's like, Jesus, that is rough living. um I am so happy that we don't have to do this today, and I can just have clean fresh water on demand as, as a service. I can have water as a service in my house. Uh, this is the same thing. This is the exactly the same thing, but with metaprogramming. Whoa. Okay. So, what are we do? What are we doing today? Actually, you know what? I'm gonna meme about this a little bit in the Italian Zig Telegram group. And I think we have this in Meta, right? Okay. So, what are we doing today? Maybe I should give an update on what I was doing yesterday and what I ended up um, doing in the end. So, I wrote a blog post about my simplistic column safety system. So, to quick recap, I have this. I'm using Carl Seguin's SQLite Zig wrapper, and it's very thin, so it's idiomatic. Like, so, like when you're using SQLite, you do this thing where you want to refer to column names in a query result, well, in a row, by position. You use position annotation. So this one is origin, two is channel, but obviously this can get wrong very quickly because I don't know, you just mess up one index and now everything is wrong. And maybe you catch this error because you're trying to read as an integer something that is instead of a string, or vice versa. But if you mess around two things that are the same type, then you will only find out at runtime, and maybe not even that quickly. So it's error prone. How do you make this less error prone? Well, what would be nice would be to be able to do this. Instead of doing int 0, you do .id, .origin, .channel, .author. Like, you can use names to refer to columns. So how did I ended up implementing this? In the dumbest way possible. Make a type generic over the query. So this does change one thing. This library allows you to use runtime known queries. So, like, you can make these strings, like, you can build them up at runtime. So you can make a runtime string if you want, but but in this case, I'm asking you to provide the query at comp time, but it's fine. It's like, I don't need dynamic queries, so that can be the default for me, and I would say most applications. Um, so yeah, we become generic over the query, and we just parse the query. And to keep things simple, we just do some not too enlightened parsing. We just tokenize on spaces, commas, new lines, and we expect to find select first, and then which, by the way, this is like very hard coded. That means that I cannot use this system even if the query is an insert. which is fine. But select covers the main use case, and we can make this more flexible as we need later on. So in any case, we find the select. After select, there's going to be a bunch of column names. So we start collecting those. If we see a star, then we know that we're doing select star, and we complain because you should not be doing select star. You should be name your columns explicitly. So we do that, and we stop when we find from. And this way we know the column names, and then we make a map of them, and then at comp time, whenever you want to fetch a column value, that also the column thing must be hard coded. So these values have to be comp time known. They cannot be dynamic at runtime. But again, that is fine. And it is, I would say, especially fine when the query is comp time known. Like I don't see the two things kind of go hand in hand. Um, so yeah, we basically compute the corresponding index in like the position in the original query, still a comp time, and that's it. And then internally we pass the right index, and that's it. 20 lines, more or less, done. Obviously, this is simplistic because it doesn't work for every query. It's very bare bones, but it really does a lot of heavy lifting compared to how simplistic it is for our use case. And that's it. So then I talked about other approaches, more things. Oh, one thing that I coded yesterday was also um, forcing bind parameters to be named and using named structs for those. I implemented the whole thing, like I made it work. Basically, to make that work, I would, again, simplistic approach, not general purpose, but I would check for a where token. And if where was present, then I would start looking for question marks, ats, colons, and dollar signs. Most importantly, I wanted to standardize on dollar signs, so dollar sign foo, dollar sign bar, and then I would know variable names, and then from knowing variable names, we would be able to do metaprogramming also on those. I ended up taking this out because it's not really that important, and it also was fairly limited. It's not. I would say that it's much more likely to get this stuff wrong than to get the other one wrong. So for now, I'm just gonna leave it at this. I do think that it would be nice to have a database library that does this stuff, and the ZQ, is it ZQLite? No, it's Zig SQLite. Well, the one from V Richman, that one does all that stuff. Mm, but I think it goes too far. I think it uses comp time a little bit too much to provide too much type safety in a way that is, in my opinion, it's not what I would want. It's not the way I would want things to work. In any case, that is the end of my adventure. So now we have queries with a little bit of type safety attached to them, and also text that automatically makes you dupe so that you don't forget to dupe. And yeah. So this part is, I would say, so far so good. The next thing that I want to look into a little bit is permissions and rate limiting. I think I want to start with rate limiting. So I don't have a full precise model yet of how I want rate limiting to work, but here's what I know. It doesn't go on the database. It needs to be something that we keep in memory. It obviously needs to be very fast because we will consult the rate limiting thing very, very often. And actually, now that I think about it, rate limiting is per connection, should be per connection and also per user, maybe. So there should be limits in, or you know what? No, I take it back. I think rate limiting should be entirely per connection. So every connection has a uh has a local variable that keeps track of, I guess, at the baseline, how many messages it's sending per second or receiving, sorry, per second from the client, how many requests. And there should be limits there. Then the question is, I think rate limiting should be about messages, um, connection attempts. Maybe we could make a distinction between query requests that are read only versus requests that also write. I don't know, but I think that's what rate limiting should be. Then there needs to be another system which is kind of like rate limiting, but it should be um, domain specific, and I think it needs to be a separate system. So the idea is you want to limit how many messages a given user at that point, not client, a given user can send per second. So maybe you could say that in general, users cannot send more than 3 messages in within 5 seconds, something like that. There are probably better, more nuanced ways of expressing what I just said. So not like, yeah, there's probably more cuter formulas than what I just said, but yeah, that I think should be how it works. So that means that rate limiting should be a thing that when you hit rate limits, you get added to a, like, your IP address is added to a firewall rule. While instead, if you violate permission level rate limits, then you like get timed out. Like you gain a role that restricts your stuff even further, maybe that kind of stuff. Is there a way to write code? For example, write a piece of software like lib lib3 lib3 libtre. I have, oh, LibreOffice. Okay, and test how much memory it uses, and then write an allocator to use x number of memory over that. I'm having trouble understanding what you mean by write an allocator to use X number of memory over that. So you can know how much memory LibreOffice uses. Well, I think we would need to be more specific, right? Because LibreOffice, I believe it's a collection of programs. So the word processor, you can launch the word processor, and then yeah, you can read from the OS uh, how much memory that process is using. Sure. Then what would you be able to achieve by writing a different allocator? A different allocator could have a more fine-tuned memory allocation strategy, and that could reduce the amount of memory that the program uses. Yes. If you're asking if you can make an allocator with a specific amount of memory, then yes. Yes, you can limit, you can create an allocator that limits the total amount of memory, but but um the application has to collaborate with you, meaning with LibreOffice, it would be more complicated because you kind of cannot do it at the allocator level because um, LibreOffice probably dynamically links against libc. And so it uses the allocator that everybody else uses, I guess you could um, sneak in a new definition of malloc that is only used by LibreOffice, and I guess everything should might work. Not I'm not sure if it will, but uh, it's likely that it will work. But even then, I think your OS should provide a kind of primitive. Like I sincerely hope that your operating system is able to put resource limits on a process, including how much memory it can use at most. I've never I've never done it myself, but yeah, if it is an application that you control, then sure. We have that in Zig. Std.heap. Uh, I think debug allocator, for example, has that in its config. Enable memory limit. If true, the allocator will have two fields: total requested bytes, which tracks total allocated bytes of memory requested; requested memory limit, which causes allocation to return out of memory when total requested bytes exceeds this limit. So yeah, we have an allocator where you can specify that stuff. Still, I would need to understand what your use case is more in detail to know if this answer makes sense or not. Because some things, like if your point is, I want this program to never use more than X memory, then my answer would be that you probably need your operating system to help you with that. And that doesn't require you to change any program. You can do that to programs that you compile yourself, that you own. You can do that to programs that you don't own and you don't want to modify. So it's kind of the universal solution. If instead you're talking about like your own project, like I want to make a program that guarantees that it never uses more than thought memory, then maybe yeah, using an allocator is the right way. Although I would still pair it with OS limits. But yeah, you can make an allocator, and if you do it in terms of OS limits, then I guess when you get over, you just crash, like your program just dies normally. Well, if you do it with an allocator, here you can handle out of memory gracefully. Like you can attempt to allocate, observe an error code because the allocation did not succeed, and then do something else. Maybe free some other memory. For example, and this is actually maybe not every program can do it, but it is realistic. So, for example, here Borg keeps collecting chat messages, and I never designed like a memory management for Borg. I don't know. I plan to do that eventually, but it's not critical. But a well-designed Borg could do this. It keeps accumulating history up to maybe a limit, and then when it hits that limit, um, whenever it needs to allocate memory for a new message, it starts removing all messages. It starts forgetting all messages. And that is fine for a chat application of this kind. Like if you're hitting resource limits, then obviously you want to let go of the oldest part of your history to make space for the new stuff. Why not? That is perfectly fine. Okay. What do we want to do next? Next. Let's look into rate limiting. So the assumption is rate limiting is per connection. It's domain unaware, either entirely or almost entirely. It's a local variable in the coroutine that reads from the connection. No locking, no weird concurrency things. So just a local variable, as fast as it can be, as lightweight as it can be. So we're going to run, and it's going to be in the connection manager. No, it has to be in TCP. TCP accept. Client manager. Sorry, it cannot be in client manager because client manager um, does not deal with reading. We need to do that locally to the thing that reads, which is client TCP read. So here we create a rate limiting variable, and basically here we validate the rate limits situation. Another thing that I wonder about is, can we add firewall rules from here? Is this a bad idea? Is this a thing that applications should not do? Because I kind of want to do it. Also, to be fair, that also assumes standardized um, firewall thingy, which I don't know if it's the case. And also, I would say this is just a Linux. This is a Linux only feature. Like, if you're not on Linux, then you're not being serious. Uh, then it's not like a serious server. That's for sure. Is it possible to run the software and as the code runs, it builds the allocator on the fly to expand the amount of memory? Man, I have no idea what you're talking about. To expand that amount of memory. What does expanding an amount of memory mean? I I don't understand what you're trying to achieve. I want to try Zig, but the manual memory management gives me pause. Does that make me weak? The manual memory management stuff is not that hard. Um, the interesting part is that you have no runtime. You have direct access to what the OS allows you to do and what the machine allows you to do. That is not taken away from you by the OS. So that is the good part. It's actually liberating and exhilarating. Also, the fact that there is no runtime, the fact that there is no magic, it makes it so much easier to understand what your program is doing, what's going on. I opened Python. What was it, yesterday? And I tried to do stuff in Python. It's like you feel a lot more helpless in Python than you do in Zig, because in Zig, like, you can always get to the bottom of it. You are near the bottom of it already. In Python, it's either it works or, man, you just have to give up. In my case, I was trying to import a dependency, and also I was trying to install a dependency and it wouldn't install. And then I was trying to, and then I did install another dependency, but it had a runtime error because it wasn't finding a symbol in some DLL. And the thing is, I know in theory how to diagnose a non-found symbol in a DLL, but the problem is that there is so much crap between me and that, because I would have to learn how to. I would have to look into the build process of that dependency, and then I would have to figure out how to get a copy of that dependency, modify it, and be able to load it in my environment with Python. But also, I was using Python through virtualenv because my system Python doesn't want me to mess around with packages, and there is like so much crap in the middle that it's just too hard. While here, you almost never have too much crap in the middle that prevents you from getting to your end goal. Except maybe when you pull in a C++ dependency. When you pull in a C++ dependency that is big enough, then there's going to be another pile of crap between you and the bottom of it. But which is why I tend to avoid C++ dependencies when I can. But it's yeah, it feels so good. It feels so liberating. I actually have to burn way fewer brain cycles programming in Zig than programming in a higher level programming language, because you never know what the fuck is going on in a higher level programming language. Why is this slow? Don't know. Why does this dependency doesn't work? Don't know. It's why does it work in one way on my computer and it works in another way on somebody else's computer? Don't know. Eh, I I am never going back to an ecosystem where I'm that helpless. So, hello, Rocker Rager. So yeah, that is my experience. To be clear, I studied bioinformatics in university. We were doing like my classes were in. They wanted you to use Java. I didn't do much Java. I would do most of my stuff in Python. And my first paid job was doing a Django website in Python plus an e-commerce side. Um, I've done a bunch of JavaScript. I've done a bunch of Go. It's not like I don't love the low level. I went to it relatively late in my um in my education. At the end of it, actually, I was out of university. Well, I mean, I did a little bit of C while in university, but I was never in love with it. And then I started doing Zig afterwards. And so my point is that I'm not saying this from a perspective of, somebody who truly loves the low level. I don't. But I like being able to have control over the stuff that I'm building. And ultimately I am way more productive and effective using these languages than I ever was using higher level programming languages. Because the promise of a higher level programming language is that you're more productive in it, right? Than a lower level programming language. And there's certainly some truth to that, no doubt. But in my case, I I would just feel I would feel weak using a higher level programming language. I would be much weaker than I am using Zig. For example, here I wrote my static site generator. I wrote it in Zig in I don't know, diagnosing problems. I made it super fast also, but it wasn't super fast right away. I was able to make it fast because I was able also to like profile it and really understand what I could or could not do a certain way. If I had done the same thing in Python again, um, well, Python is inherently slower, so let's set that aside. Obviously, it wouldn't have been competitive. It couldn't have been competitive. But also, on top of the fact that it's an interpreted language, so it's inherently slower, there's also the problem that, for example, I build pages in parallel in my static site generator. Obviously, why wouldn't you do that? Well, if this was Python, then and if I wanted to do things in parallel, then there is a problem because I can choose between multiprocessing, which means that you don't have shared memory and requires ferrying data around. I could alternatively I could do multi-threading, but then there's the global interpreter lock, and that also causes trouble. And then I actually did this. I did one time on stream. I tried to make a tiny toy static site generator in Python, and I got a GIL-less build of the Python interpreter because the new Python interpreter has a GIL-less version, so there's no more the global interpreter lock. It was slower. It was slower than the one with the GIL. No, actually, maybe it wasn't slower, but it was like maybe 20% faster than the one with the GIL. So long story short, it's not completely GIL-less. There's still some stuff that's happening in there, but like, how do you understand what's going on in there? Like, how do you know where the GIL thing is doing things that are problematic? Like, how do you make it better? You can't. The only thing that you can do is bend the knee and spread your cheeks because and let the GIL go to town, because that's the only thing you can do, realistically speaking, unless you decide to become a C Python developer. With Zig, you don't have to do that. With Zig, for example, um, originally I was using a dependency. I'm using a dependency called tree-seater. You probably heard of it. It's the thing that does syntax highlighting in all modern editors. Um, and turns out that tree-seater, I was using tree-seater because I do build time syntax highlighting for your code snippets. So whenever you have a code snippet, if we have the grammar in the static site generator, we syntax highlight everything at build time, sorry, so that people don't have to do that with JavaScript at runtime. Like clients don't have, like if you don't have even JavaScript enabled in the client when reading the website, you still see syntax highlighting because it has already been done when building the website. It doesn't have to be done at runtime by JavaScript. So that thing was weirdly slow at doing one thing, at loading syntax highlighting queries. I don't know why, but it was weirdly slow at it. Again, it was a dependency, so every time there's a dependency in the middle, you don't have full control over it. But by being able to profile everything and understand that there was nothing else weird going on, it was just that, we were able to find a workaround. In particular, on your side here, implemented the workaround. So I don't think that if I had been using Python and I were to use tree-seater, I would have noticed. I wouldn't even be able to notice that that's what was going on. First of all, because the Python thing would have been orders of magnitude slower than whatever silly thing tree-seater was doing. But then also, if you're just a Python developer, like how do you work around an issue in a C dependency? So there we go. Hey, Kubi man, thank you for the raid. Hello, everybody. Holy cow. That's a big raid. Hello, hello. Welcome to the stream, everybody. We are talking about high level versus low level programming. Somebody was asking, so by the way, I program in Zig. I work at the Zig Software Foundation. I work on the Zig programming language. And I'm doing right now a chat application, a self-hostable Discord alternative written in Zig. And people were asking, well, there was this discussion about manual memory management and whether, how much harder it is to write Zig or a lower level programming language. And my answer was kind of, yeah, to some degree it is harder, but to some degree it is easier because you never know what's going on in higher level programming languages. So yeah. Wanted to create something similar for a while. Yeah, there's probably a lot of us who want to work on this stuff. So let me show you, let me do a demo then. Let's see a demo. Okay, server running. Run client. We need to rebuild it. You know what? Might take a while. Let's make a non-release build of the client. Okay. So, it doesn't look good. It's not meant to look good. It looks bad. I'm aware of this. I'm using a UI framework called DVUI. I promise you can make good looking stuff with DVUI. That's a me problem, not a framework problem. But it's fine. My point right now is not to make the UI particularly good. My point right now is to implement the infrastructure correctly. So check this out. This is a voice channel, this one here, and I can join it. But let me see if the server is in echo mode. Okay, I'm running the server, but not in echo mode. So it means that if I join here, then I'm not going to hear anything because you normally don't hear yourself back in a voice channel. So to test as a development feature to test this stuff, I have the echo. So I'm making a build of the server that has echo mode enabled. And when that is enabled, you hear yourself back. Also, notice this. I'm killing the server right now. And you can see here that we are resurfacing information in the UI about about the fact that we're trying to reconnect. This is table stakes. This is obvious something that you need to have in a, I don't know, half decent application, but there are some choices to be made. Like you need to develop some patterns in order to know how to properly synchronize threads that are doing business logic versus with the UI. In any case, we have this thing, and when you rerun the server and you reconnect successfully, then everybody's happy again. Okay, let's try to join the voice channel. Test, 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 test. Okay, so on you can hear the echo on Twitch at least. Let me leave. So people on YouTube, you did not hear any echo because I have music playing and you're not hearing the music. You're not hearing that audio source on YouTube. So sorry. But people on Twitch, you heard the echo, and that was me speaking into my microphone, taking the audio input, compressing it with Opus, sending it to the server, this over UDP, the server sending it back to us, and us decompressing it with Opus and playing it back. If we had other people in this voice channel, then you would also be able to hear them. And I've done already calls in the past with multiple people, and it works. It works. So that's what we have. What I've been implementing the last few days is database persistence, stuff like full text search. So for example, maybe I should do it here. Yeah, so for example, if you remember, I had some messages with colors and fruit names. So here I have a query. I have a CLI interface that allows me to search messages and do full text search. You know, you can use star. You do B star. That will match blue and banana. It's using SQLite's full text search engine. So the last couple of days we've been well, not more than the last couple of days. The last few days we've been looking mainly into database stuff, like what the schema should look like. I didn't know how to do full text search with SQLite, so I learned how you set up that stuff, which is here. Here we create a table for messages, and here we create a virtual table that does full text search on this table. And then I have a trigger that whenever you insert something in messages, it gets also reflected in here. Although we are kinda missing a couple more, because we need also to have a trigger for deletion and a trigger for update. And we don't have those. And you know what? Maybe that's what we could look into. No, you know what? I still want to do my rate limiting. In any case, the next thing that I want to look into for today is rate limiting. So the idea that a client starts sending you too many messages, and then you ban that client. Like you straight up stop, you ban that IP address for a while. And I think I would like also to have the ability to escalate this to the firewall. So I would like to have the ability to say, if a client is pesky, we hard ban the IP at the firewall level. So I was wondering also, so another thing that I want to look into today, I think that implementing rate limiting should be very simple. Like it's just a matter of finding, an appropriate data structure and algorithm for it. So I think this is a well understood problem. What I would like to do is, well, okay, there's this thing where you can ban an IP at the application level, but that still means that the OS will accept those connections for you. And if somebody is DDoSing you, then those IPs can still choke your server. And a better way of doing this would be to use a OS level firewall. There's even better ways, which would be to use a firewall in a separate device, even outside of your machine. That would be even better. But I don't know much about that. I don't know what's standard, non-standard. I don't know if it's even appropriate for applications to manage the stuff. Login from app and fail to ban rule is an option. Yes, the fail to ban stuff, that is the stuff that I'm thinking that would be nice. to manage from the application. So what I would like to avoid is logging the problem and spamming an admin to say, dude, you need to add this, you need to ban this IP uh, manually. I would like for that to happen automatically. So yeah, now that I think about it, fail to ban is the standard way of doing this, right? And you can assume that it will be present on the server. And I think you should be able to manage that from your application, and that's it, right? So I think that's what I want to look into. Also, I'm fine with this being Linux only because it, I mean, if you're making a serious server, like if your server is serious, it's going to be running on Linux. It's not going to be running on macOS or Windows. Uh, yeah. So let's look into this stuff. Because you should give it a regular expression and point it at a log file. Oh, I didn't know this. That, by the way, this is I knew about this system. I didn't know that was the way. Okay, so it's not even interactive. It just you just log those things and then it automatically issues bans. Bam! I love this. That is so good. Okay, so does that mean that then I don't have to do anything on my end, like at the application on the application side? I just need to log those rate limit failures in a way that is, that you can put a regex on it, and then everything else. Well, but wait, is that setup that you do in your system the script then? Like, does fail to ban? How does the setup of fail to ban work? It requires extra setup outside of the application. Yeah. What about having the application try to launch a command whenever this stuff happens? Is that something that happens commonly? In the meantime, give me a sec. I'll be right back. I'm gonna get on a cup of tea, and then I'm gonna start looking into stuff, like googling and learn more stuff. Also, if anybody has suggestions on like what approach to use for rate limiting, like the algorithm to use in the application itself, I'm all ears. Okay, I'm back. Let's see. You create a config file for each application in fail to ban and then instantiate it with settings such a path in the actual installation. The advantage of fail to ban is that it can work with things like firewall D and UFW. Huh. Rate limiting idea. Not sure if this already exists. Every user has a budget. Every action has a cost. Cost scales 1 over T, where T is the time between actions. Successful rapid actions are very expensive. So Rocket Rager, seems a very interesting idea. I think for a chat application, probably you could get away with something more bespoke per individual use case. Like you can do only up to 5 messages per second, something like that. That said, I think this is a great idea. But this is not what I want to consider rate limiting. I'm gonna say. So here's what I was thinking of doing. I think there needs to be like two different levels. One is what I'm defining rate limiting, which is per connection, and that should lead to you getting firewall banned if you go over limits. Then there needs to be and it's not domain aware at all. It's just based on stuff sent from clients. Then there should be a higher level system, which is still in part rate limiting, but I'm calling it in general. I think it should be in general the permissions system, where here we have permissions. This schema might not be enough to fulfill. Like I prototyped this like a year ago, so I haven't looked into it for more than a year, so I don't know how good this is. But my point is, then the higher level system is based on domain specific rules, like you can only do so many messages per second, or maybe we could generalize it using this rule. But the idea is that if you go over that limit, you don't get firewall banned, you get muted. Maybe you maybe there are some negative consequences, but those are not getting firewall banned. So right now, for now, I'm looking at this one, which is the one that gets you firewall banned. Sounds like token bucket. I use that in Zigbee. Pretest for chat is it allows for a bit of bursting, but not sustain spam. Okay. Because I think that what leads you to getting firewall banned should be a much higher threshold than what leads you to getting muted. Because I think that even a spammer account can be completely disruptive and ruin your entire application, even with a level of posting that is, in my opinion, maybe not high, like that shouldn't be considered high enough to justify getting firewall banned. That said, here's what I think. Here's a twist on your idea. Maybe rate limiting, not this one that gets you banned. The rate limiting, the permission based one, the one that is domain specific. Maybe that one shouldn't be based on the cost of successful actions. I think it should be based on the cost of unsuccessful actions. Meaning, if you keep being told no by the server over and over and over, after like, let's say 10 times in a row that you get told by the server, no, you cannot do this. I think at that point it would be justifiable that you're forcefully logged out for like an hour or something. Maybe this is a bit too harsh, but that's the idea. Like the idea being, maybe it's not successful actions that should be a cost on you. It's unsuccessful actions that, or rather, I guess it would be like Yeah, maybe you keep this to decide when an action should flip from being allowed to not allowed. And then once you start going into the realm of not allowed actions, then there's a similar system where if you keep getting rejected, after a while you get you just get kicked out. But also those are per user, not per connection. It would be nice to firewall ban people for specific styles of posting, even for low frequency. Like if you post to more than a couple of channels within a second or two. Yeah, that is a good point. That is a good point. That is a really good point. Although, yeah, man, we're gonna need to build so many tools for moderation. It's not fun, but it's necessary. Like I've run enough communities for long enough to know that is necessary. Like not having moderation tools, it's like publishing this thing, like telling people to start using it for real, and not have implemented TLS. It's like it's that level of bad. It's just unusable. You're giving people something that is incomplete. Well, too incomplete. Okay, you guys were saying token bucket. Let's learn about token bucket. I might have seen these things in the past and I forgot about them. There used to be a time where I was at Redis Labs um where I was more aware of rate limiting strategies, but then I forgot. Token bucket. Okay, should we trust Wikipedia to teach us about this? Or is there something better than Wikipedia? Medium, MessageNet, Geeks for Geeks. Is that a dating site? Geeks for Geeks? Token bucket algorithm explained. Dev community. Dev.to. Uh, chances that this is good are very low. Wait. 27th of September. So this is AI generated, but maybe this is not entirely AI generated. Here's how we do it. C token bucket. Or you know what? Maybe there's a Zig one. Zig chain price today. Uh, there's no Zig version. Wikipedia is not bad. I was hoping for a C implementation that we could take inspiration from. Algorithm. Let's see. A token bucket algorithm can be conceptually understood as follows. A token is added to a bucket every 1/r seconds. A bucket can hold at most beta tokens. If a token arrives when the bucket is full, it's discarded. When a packet of n bytes arrives, holy shit. Oh, wait. You make people pay for number of bytes? Well, maybe that's not a bad idea. If at least n tokens are in the bucket, n tokens are removed from the bucket, and the packet is sent to the network. If you're the net n tokens are available, no tokens are removed from the bucket, and the packet is discarded to be non-conformant. I see. So there's a problem in our case. Whatever makes sense for your app. Yeah. I do think that in some way reflecting the cost of a message in the rate limiting system is not a bad idea. The problem is that it is not immediately obvious to us how big a packet is because we are not length prefixing them. We could change the protocol to length prefix them, but given that we don't need to, I don't think I want to do that. So I guess in our case, we can say that we can know by reading one byte which kind of message we're receiving, and I guess we can give those messages a weight, and so we can automatically, by default every message weights one, and then if there is a type of request that the client can make that is particularly onerous, then we can make that one cost more, a lot more. For example, it's not implemented yet, but if you make a request where you're making a search, like you're doing a full text search on messages, that one gotta cost more. That being said, we're kind of doing the thing where we are moving from like penalizing people for requests of that kind. Maybe should be done differently. We're kind of getting into the territory of the permission system, in my opinion. That being said, okay, that's fine. So, implementers of this algorithm on platforms lacking the clock resolution necessary to add a single token every bucket, blah, 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 want to consider an alternative formulation given the ability to update the token bucket every S milliseconds. The number of tokens to add every S milliseconds is this. Properties, average rate. Over the long run, the output of conformant packets is limited by the token rate R. Burst size. Then Tmax. If R, the maximum burst size is gonna be beta over M minus R. Wait, let M be the maximum possible transmission rate in bytes per second. Okay. Comparison to leaky bucket. The token bucket algorithm is directly comparable to one of the two versions of the leaky bucket algorithm described in literature. So why do you guys say token bucket and not leaky bucket? This comparable version of the leaky bucket is described in the relevant Wikipedia page. This is a mirror image of the token bucket in that conforming packets add fluid equivalent to the tokens removed by a conforming packet in the token bucket algorithm to a finite capacity bucket, to which this fluid then drains away at a constant rate. Equivalent. Oh, it's the same fucking thing. Um, Leaky is fixed rate. I see. But I'm not necessarily entirely sold that we need to allow for bursts, particularly for this application, because like how bursty do you get when chatting? Like, I mean, I know that you can, I don't know, go full teenager and like spam, a enter, a enter, a enter, a enter. You can do that. But even if we don't allow you to do that, it's fine in most cases. Even in moments where uh, you're typing intensely and you're not doing the single letter, single message bullshit. Um, I would say you're still going fairly slow. What else could you be doing like this? Spamming the search button? BT bot. Uh, for now, we're running under the assumption that there are no bots and that users are not allowed to add bots. It is fair to say that a bot could be something that could do this kind of stuff. Oh, sorry. I guess my point is, well, if you're talking about like a spam bot, obviously a spam bot could be interested in spamming faster, in sending messages faster. But I mean, it's my argument here is that even if we don't have flexibility for bursts, then uh, it's fine. For chat, you want a really slow limit, like one message every 30 seconds or something. So bursting is nice, so that you can at least add to your last message without getting limited. Mm-hmm. Hierarchical token bucket. Okay. Lock-free implementation of token bucket for C++11. Consume tokens. New clock. Time needed. Tokens times time per token. Mean time now minus time per burst. Old time old time, and then new time equals old time. If mean time greater than mean time, new time needed. Compare exchange week. I see. So this is synchronized. I don't think maybe we want something synchronized for the other stuff, but for per connection stuff, we don't need any synchronization. So we can keep it dumb. Okay, let's start coding it up and see where that leads us. What have I done? What have I done? Oh, I think I was modifying this and then I never saved it. Really? Mm-hmm. You happy now? Okay. macOS, why not use Linux instead? I mean, I have it here in a virtual machine. I use it sometimes. I don't know. Either is fine. I'm just editing text and I'm doing some type of programming where I'm not trying to interact with any OS specific thing. So, uh, either works. Either is fine. I have a nicer browser on macOS than on Linux. So I don't know. There used to be like I've spent I think a while ago like a year or something doing Linux first, and now I'm in a macOS first period. I'll switch back to Linux first at some point. Okay. Can we zig build, or did I leave it in a broken state? I did. Oh shit. Oh wait. I'm also in the wrong directory. Oh crap. Oh, that is bad. Really? Okay, we're back to being happy. Okay, so where do we put our rate limiter? Um, we can make it something the client and server share. You could argue that a client might want to protect itself from the server. Maybe. I guess for now we can put it in server. So we can just do server and then rate limiter. Yeah. Okay. Lauris posted yesterday about the NITF spec. I took your advice and used XConstruct and actually did use a tokenizer ask tagged switch construct. Oh, interesting. So are you happy with how your stuff is coming up? Okay, so our rate limiter, I'm probably gonna kind of steal these ideas. So they have a time that starts from the minimum time, and then they have time per token and time per burst, which are based on these things. I think that these should be calm time parameters. Oh, but if that's the case, then this guy needs to be generic. Do we want to make this type generic? Um, Neurosite and cryptocode, since you guys have implemented this stuff, do you think it's worth having those parameters be comp time? I guess it doesn't matter much because that means that we could, in theory, pre-compute those rates, but then we just compute them once. And then, yeah, I don't think there is much to gain by doing those things at comp time. Time per token, time per bust. Maybe you want a server config for those. That is fair, which that would also indicate that we do not want to keep them comp time known. Yeah, that's fair. I agree. Also, you know what? We're starting to get to a point where we have enough config settings that shouldn't live in the database. Then we might be getting to a point where we need to start having a Ziggy config file. We'll see. Um, so what were those things? Time per token, time per bust. And huh. And we need also to figure out which these types, what is it that those types need to be. We have STD time instant, I think. Um, let's see. Love it. I've done the binary format parsing in Rust and in Python. Zig is making the dev cycles faster. No benchmark yet, but the pipeline this will be used in requires low latency. Cool. By the way, is any of this code publicly available? Because if so, I would be happy to take a look and give you hints in case that I notice, something that is not idiomatic or that I can quickly see that can be done better. If not, obviously it's fine. But let me know in case. I'm happy to take a look. Temper token, temper bucket. Out of curiosity, is any of if any of Zig been publicly available? Because if so, crypto, I might, how can I say, take inspiration from your implementation if you want, or rather, if you'll allow it. Okay. It is an open source, but I just translated. Want to use? Oh no, in the TypeScript server. I see you have a TypeScript implementation. Uh, thank you. So let's see. Uh, IO capacity, refill rate per second. That makes a token bucket, and we need to SD clock real now. Okay. So okay, you're using this question. Why not the monotonic clock? Do you have I guess this has to deal with real time, in a sense. Like you cannot trust the monotonic clock to run at the same rate as real time, right? Okay. But these are actually questions that I have also in my mind. Like, can you trust the monotonic clock to run in real time? In this sense, I I read um, the monotonic clock value, the real time clock value, and then I basically use the monotonic clock to compute offsets from that time. That I will consider that starting time my official real time that I collected at the start of the program, and then throughout the life of the program, I will keep referring to that. Because otherwise, I wonder what would happen when you have those negative timer adjustments that always mess up algorithms based on time. Steady clock in C++ to avoid the issues. Okay. Well, thank you very much. Okay. Um. So this guy has now. I didn't know this. I didn't know the clock had clock dot something had now, or maybe I did and I forgot. I don't know. No, I think I don't because this gives me a timestamp. I think I'm used to dealing with instants, not timestamps. Timeout. All right. Hmm. Is this supposed to be the new API or are instants still a thing? I don't know. Well, I guess we can just switch that to monotonic and just call it a day. Let's see. Real awake. On Linux corresponds to clock monotonic. Oh, nice. Andrew gave them nicer names. Boot. Identical to awake, except it expresses the intent to include time that the system is suspended. However, due to limitations, it might behave identically to awake. Yeah, I think boot is fine. Presumably, you want more than one depending on the thing. Uh, yeah. Let's take a look at this stuff. Also, I think I wonder how nice it is for us to make a synchronized and a non-synchronized version of this stuff. In one swoop. I think we might have to make this bad boy generic after all, but not towards not with regards to the parameters, but with regards to synchronization. Because I guess alternatively we could put a mutex in this stuff, but yeah, one problem at a time. Okay, let's see. So there's take token, take token, and that's it. By the way, this code is fantastic. Thank you, crypto code. Holy shit. Rate limiter, let's see. Capacity is 5 tokens, refill rate is 2 tokens per second. Consume the first 5 tokens immediately. 6 tokens should be denied. Wait a second, allowing 2 tokens to refill. There's gonna be a point in time where we're gonna be able to make this sleep uh instant if there's nothing else running. I think we're gonna be able to do it. I think it's gonna be so cool. So that your tests, and I'm talking about specifically testing IO, basically having testing IO uh, turn sleep from a real sleep to a forward time thing when you don't have other stuff happening concurrently. Well, I mean, that's one approach. That's one way of doing it. I guess alternatively, you could say that we have that the testing IO that there's like std.testing dot fast forward clock. So maybe it shouldn't be something that is magical behavior implicit into sleep. Maybe it should be something that you do more explicitly. But the idea that in a test you can do this kind of timer stuff without having to wait the time to pass for real in testing, strictly when doing testing. The idea is to be able to test some async stuff that deals with sleeping by fast forwarding the time. Okay, thank you. Okay, so to use this, then we go into run. Here we set up our rate limiter. So this is a rate limiter of requests from a given connection. I am wondering though, you know what I'm thinking? Hmm. Okay. One thing at a time. So var space k space k IO capacity. Okay. So capacity and refill rate per second. 5.1. I don't know. Oh, I cannot do dot init. Okay, let's do catch. Let's do try. Um, then in here, why is it top right? Wait, this menu used to be centered. Why is it top right now? I guess it's because it only contains small thingies. Oh, okay. So this is a take one token. Okay, this is not like weighted. So take token. This can try right with uh. Okay, you know what we're doing? We're doing this. And we make the error set. Oh, this returns a bool. Wait, so this means that the error set is not necessary. So error.rate limit. I would even say that I would prefer this to work this way. Perfect. LF1 return through. No, I think it's fine. I did mess up this though. Mm, 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 mm. I think I fixed the tests. We'll see. Okay. Okay, so I guess this is it for messages. So connection. Here's the thing. This is easy, right? Because this is one bucket per connection. We keep it here in the function frame. It's like very local, uh, extremely straightforward. But also here in unknown request, we need to close the connection. Although you know what? No, that can be we can abuse this to test our rate limiting. Let's see. Sig run serve. No, this one, server run. Okay, so we can do now. We can netcat connect. And then we can do some spam. Uh, just numbers. None of those will be picked up as a thing. Boom. Unauthenticated client send us wrong marker. Oh fuck, right. But there's the thing where you need to pass authentication before you can move forward. Okay, just temporarily comment out this part. Any news like discussions about different things to work on to be added that you can spoil? Right now, the majority of the discussions are about async IO and how to model that, the semantics, the features to add, what to prioritize. So that is where the main discussions are. Related to async, what is interesting there? So we're getting cancel protection. IO.Q is about to have also the ability to close because we were using IO.Q is our channel. I think we should rename it also to IO.channel. I'll pester MLAG and Andrew about that more soon. But if they haven't done it yet, so IO.channel will have the ability to close. And by the way, my definition, which I think it's a good way of going about it, is you can have a queue. You can have a synchronized queue. Our IO.Q is not a channel because it's just a synchronized queue. It's a data structure plus atomics for synchronization. Well, no, locks. I think it's not just atomics, it's also locks. And then After that, if you want your thing to be called a channel is a synchronized queue that has the concept of closing, of being closed. And so, yeah, we're about to have that. There's a gigantic patch from Andrew that will move a bunch of file system stuff um, to the new IO interface. So some people, if you've been using is unstable builds of Zig recently, sometimes you find out that some APIs have not been ported to the new IO interfaces. So, for example, you want to do walk dir, you can only do walk dir with an SCDFS dir, not with an SCD IO dir. This is all like super annoying, and it's just an artifact of the fact that we are like in the middle of moving. What logging package are you using currently? Looks good. It's std.log. It's in the standard library. Is there a Zig library for JWT validation? Good question. I don't know. We certainly have all the crypto primitives necessary to do JWT validation, but I don't know if we have libraries that know how to parse, the JWT string thingy correctly. I would not be surprised if Frank Denis has one. So I would Google Zig JWT and see what comes out. Okay, so here we started. Let's connect. Let's spam stuff. The connection closed. That is good. Let's see what we got here. Unauthenticated client sent us the wrong marker one. Exiting. Oh, god damn it. Wait, did I not save this file? Did I... What? Oh, I need to comment this out as well. Okay. Oof. We're getting there. Wait, what? Assertion failure. Yeah, I know, but wait, did I not comment that out? Oh, there's another one. Oh, there's one in here. Okay. Man, I'm making it too hard to break my own code. Let's see. Client request 1102994. Connection exceeded rate limit closing. Boom. Okay, so this is good. We tested it. Now here's the next problem. Okay, this one is nice and easy. Here's the next problem. The next problem is now we need to do the same, but in a hash map because we need to remember things like per client, well, per IP. Even after the IP has disconnected, we need to remember stuff. And like we need many of these bad boys. So we need a hash map that forgets. We need a hash map that forgets. We are starting to reinvent Redis, basically. So what is the idea? The idea is that client manager, I think we need to have like we need to start also a janitor thread that does like janitorial work basically. Well, the basics should look like this. TCP run accept. Here we accept a new connection, and we spawn a client manager to handle it. Before we do that, maybe this can be done better, like new connection, and then we do stream dot address maybe. Does it have a formatter? No. Reader writer. There's a socket. Does socket have a formatter? It does not. Bro. Bro. Really? Oh, wait. Socket has handle and IP address. Wait, why did I not see this sooner? Let me double check. Stream. Stream has socket. Socket has address. There we go. Okay, nicer debug message. But here we need to have our like leaky bucket hash map. Auto hash map of io.ip.address IP address, and values are rate limiter. We start empty. Trying to understand mutexes seem like a waste these days, because are my 5 users now with rate limiting really going to blow up my stuff? Well, as long as you have 5 users, no. But then when you have 6 and things start to get spicy, then you will thank God that these things are in place, because otherwise there is no way you would be able to keep control over your shit. Mm-mm-mm-mm. So here we go. Okay, what's our default? What's our default for allowing connections? And here's also the thing. Here is also the thing. What we're missing here with the current implementation is the ability to um to penalize a connection that was forcefully disconnected because it was spamming. right now, you losing your connection, like you're on a spotty network and you drop the connection, is the same as you being kicked out because you were a bad actor. So this is a problem. This shouldn't be like this. So here's what I'm thinking. I'm thinking that we need to have like a janitor, and the janitor needs to have like a queue, and we have to lock it somehow. We, man, I think what we would want is a synchronized map. I think we would want to have a synchronized hash map. I think that maybe what we would want is a Go style synchronized hash map. We don't have any of that in Zig. Well, in the standard library, for certain, we don't. But in the Zig ecosystem, I don't think we have any of that. Oh, well, Carl was into all this web stuff, so never mind. There we go. Thread safe, exclamation aware, LRU ish cache for Zig. Let's see. Get will return null if the key is not found. Yeah, cache user int allocator max size. Interesting. If the entry has expired, it will be removed. This is almost what I want. By default, each value has a size of 1. Thus, given a max size of 5,000, the cache will can hold up to 5,000 items before having to make entries. The size of a value can be set when using cache.put or cache.fetch. What? Let's see. Implementation. This is a typical RU cache which combines a hash map to look up values and doubly linked lists to track recency. To improve throughput, the cache is divided into a configure number of segments, defaults to 8. Locking only happens at the segment level, yes. So that's what I was describing, a synchronized hash map. Furthermore, items are only promoted to the head of the recency linked list after a configure number of gets. This not only reduces the locking on the linked list, but also introduces a frequency bias to the eviction policy, which I think is a welcome addition. The downside of this approach is that the size enforcement and the eviction policy is done on a per segment basis. Given a max of 8,000 and a segment count of 8, each segment will enforce its own max size of 1,000 and maintain its own recency list. Should keys be poorly distributed across segments, the cache will only reach a fraction of its configured max size. Only these recently used items with a segment are considered for eviction. Yeah. Okay, out of curiosity, what else does Carl have? We might at this point we might as well look at everything that Carl has. Postgres, HTTP, WebSocket, uh, ERB inspired templating language. Oh, ERB. MQTT, structure logger, metrics for Prometheus, SQLite, DuckDB, cache, SMTP client, validate the Ziga validation library. What does that mean? What is it validating? Oh, okay. Oh, one-time passwords. Localize. Single flight. Duplicate function call suppression. What? Multiple threads can call group.load on the same key. Oh, glob glob. Oh, there's a Go implementation. Okay. I mean, we could use this. But this is not saying what the key is. Why is this? Oh my god, this library is forceful. It's forcing you to use strings for keys. Eh, eh, it's in the right direction, but it's not exactly what I need. You know what? We stay with the worst solution until we upgrade to a proper solution. Let's not upgrade to something that looks good, but it's actually not good for our use case. So let's stay with the stuff that is obviously suboptimal, and then we can upgrade that, I guess. Or we can leave it as a to do. To be honest, for now, I think this is fine. So how to hash map, blah blah blah, get or put init 10.1. Well, no, these are floats, right? Yeah, I think the refill rate should be lower than 1, like 0.2, and you start with 5, something like this. I think we want to do maybe 2 of those. So what is it? Should this be what gets you banned? Hmm. Hello, X2. Mm, I feel like this is too defensive. We don't need this level of defensiveness. Okay. So this is it. Um, so this is the idea. We tag it with fail to ban, and that's it. Or we can even do it like this. I think this is even easier to parse. Fail to ban tag, IP address, space. Um, so this makes it obvious for file to ban. Hello, Ron. Is async IO different from async function in Rust? Is it stack based or stackless? Also, do we have a way to do async function in Zig as in Rust? Um, Async in Zig is very different than async in Rust. Rust is based on stackless coroutines. Ours right now does not. Our async right now can do multi-threading, green threads, think of like Go, and stackless coroutines are a proposal. We might end up in, we probably will have it, but we don't have it today. And as to do things like in Rust, well, I don't know how to answer that. You do async in Zig the way that you do it in Zig. Like we have our own way of doing it. It's not a one to one to what you would do in Rust. So, uh, but it, that so you can do it, but it's not the same as doing it in Rust in terms of syntax. I mean, so here, for example, look, I am doing async. I'm creating an async group, and then I'm launching a bunch of coroutines. And I'm not using async. I'm using the concurrent keyword. There's some nuance there, but async and concurrent at a high level, you can think of them as roughly the same thing. Again, there's some nuance there, but it's not important right now given the questions that you asked. And so I'm basically spawning a new coroutine per connection. Every time I have a server connection that I keep accepting connections from, and every time I receive a new connection, I spawn a separate coroutine for that connection. And if we're using an IO implementation that uses multi-threading, then this will be one thread. Every connection gets its own thread. If it's green threads, every connection will get its own, well, green thread. So kind of like Go. And with stackless coroutines, we will have stackless coroutines, but that's a story for another day. Okay. So this is good. Not perfect, but this is good. Failing authentication should consume rate limiter. Um, There we go. I saw an issue where there was work on making a struct elisioning mechanism for stackless coroutines like Rust. Is it getting cancelled? A struct elisioning mechanism. Are you talking about reducing frame size for stackless coroutines in the sense of um, like reusing memory assigned to variables when that variable is not used anymore, that kind of stuff, which already normally happens for normal functions? Is that it or something else that you're referring to? In any case, Zig right now does not have stackless coroutines. The plan is to have them in the future. We now have um, well, so setting aside what we have now, yeah, the plan is to have them again in the future. There used to be a problem that our stackless coroutine frames would be chunky because we didn't have the analysis code that would be able to know when it is safe to reuse memory, stack memory, because you define A as an array, then B as another array, and then you use A for a bit, then you suspend, and then you're not going to use A again, and then you start using B. So in theory, A and B could live over the same memory, and that is an optimization that does normally happen in functions. But for stackless coroutines, yeah, it's a bit more nuanced. Uh, being able to do that, and yeah, we didn't have that. Hopefully, we'll have that in the future. Okay, I think that with this we have the basics of rate limiting. Now with this we have the like yeah the super turbo basics. We need next. Also, you know what? Let's move this here and here. Also, you know what we're missing here? Timeouts. You know how async functions are basically chained to a struct that is a state machine in Rust. Um, yeah. So let's return this assert. Let's return this assert. Down here. Okay. Uh, okay. So what do we want to do next? So we have rate limiting, the basics of. Next, we need to look into permission level rate limiting. So that one is going to be more complicated because it's per user and it has to do with online users. No, that's actually not even true. It doesn't exactly have to do with online users. It has to do with um well, because you could go offline and then come back online, and if you were doing something like intense, should you start with a clean slate when you reconnect? check this out. What I just got via email. I got tired of opening my browser for Jira, so I built a NeoVim plugin. Jesus Christ. Oof. Wow. VS Code diff.nvim. But wait, I understand diff, but what is VS Code diff? Oh, VS Code style side by side diff rendering with two tier highlighting. Jesus. Okay, there we go. This is what I wanted to show. PSA gitportal.nvim, which I don't know how popular it is, has moved to Codeberg project link. Inspired by leap.nvim and Zig, Gitportal is now hosted on Codeberg. Codeberg is a community run non-profit open source software development. I'm gonna copy this. Uh, anyway, so they just moved. Okay. It's a small extension. It's not gigantic, I guess it seems, but good for them. And it's kind of sad that this cache thing is so close to what I want, but not exactly there. Oh well. Okay. So permission-based rate limiting. This one is interesting because it's per user. We do want to keep it in memory. We don't want to keep it on. We don't want to persist it. We don't want to forgive users when they disconnect, meaning that even if you disconnect and you consume some abstract resource, your bucket shouldn't refill completely when you reconnect back. So that means that we need an array of these things. Feels like lingering state for a while is what you want. Clean slate is too easy to game. Yeah, yeah. I mean, in if you know the fact that this stuff is per user, I feel like it's fine to not even say that it's like you do get like your stuff gets freed from memory, but after a while that you disconnect, it's not even that. I think that it's fine for the server to pay a fixed cost per user, per like registered user in memory when it comes to this stuff. It doesn't seem to be too costly. Obviously, we need to try to keep the thing small. And that needs to be global and synchronized. And when you add a new user, when a new user signs up, then we need to like reallocate. Well, we need to resize it. So it needs to be an array list. An array list of rate limiters. Hmm. Yeah. So let's see. How synchronized does that stuff need to be? Let me think. Um, well, I think the whole thing needs to be locked. You know what? Maybe it's just part of the state. I think this is part of our state, and we just lock it alongside everything else. No, it's just a release now. And by making it an array list, I think we can literally. Let me think about it for a second. Let me think about it for a second. If we make it an array list, we can literally index by user ID. Our user IDs. Oh, you know what? This also goes back into the conundrum of um, which kind of IDs should we be using for these things. And I think, that, for example, users don't have sequence numbers. Uh, let's see. What's users? No, it is. It is a primary key. It is a auto increment primary key. So we could use user IDs, but then you have a problem where you have, let's say, I don't know, 10,000 users and 99% of them are gone forever. And now you have to load into memory information about them no matter what. Um, so we could make it a hash map. And then there's a janitor that occasionally frees the memory, like removes basically users that are disconnected, who have been, whose uh, limits have completely reset. Hmm. There is something nice though in having just a straight up array list that you index into. And we want to like run this code at every single interaction. Huh. Don't know if you have discussed this, but for async and await IO changes, are there plans for the standard library to have some predefined implementation like there is for allocators? I'm assuming yes. Yes, we have discussed this. Yes, there are standard implementations. Right now, the one that works is called io.threaded, and that one does multi-threading for uh, as the unit of concurrency. So every time you do async something, you spawn a new thread, roughly speaking, or you don't necessarily spawn one, but you use one in a pool. But that's the idea. There is going to be another one which is currently called io.evented. It exists, it's just not functional. That one is green threads. So that means that it will have a pool of OS threads, maybe 8 if you're on a 8 core machine, for example. And then you will be able to create a, I don't know, borderline unlimited number of green threads, as long as you have memory on your machine. And then those green threads will be multiplexed on OS threads. So there will be an event loop that does that decision making. That is kind of like how Go works, roughly speaking, except that you don't have a magic runtime in Zig the same way that you do in Go. So you have an event loop, but like you will have to manage it manually a little bit. Then there is a proposal to have stackless coroutines. If the proposal for stackless coroutines is accepted and implemented, then you will have the ability to also have an evented implementation. So I don't know if it's going to be a different implementation, or I think it might even be that it's going to be the same implementation, but you just specify if you want green threads or stackless coroutines. I don't know. Either way, there will be also the ability to do stackless coroutines, but the stackless coroutines require the compiler to help you out. Like the compiler needs to uh, do code transformation, while green threads, for example, does not. You don't need the compiler to cooperate to be able to pull off uh, green threads. So long story short, today it's threads. Soon it's going to be green threads. Eventually, probably it's going to be stackless coroutines. Although I wouldn't necessarily assume, I can tell you that green threads are an upgrade from OS threads, but I wouldn't necessarily assume that stackless coroutines are an upgrade from green threads. More nuanced. There is some known relationships between those things. Like it is fairly known, how Go performs versus, I don't know, Rust when doing async. But they will have. There's also some other proposals, one of which has been accepted, called restricted function pointers, that will have a big impact on how it will improve the green thread implementation significantly in a way that other languages have never been able to. So at that point, I think the green threads will probably be the go-to implementation for a lot of people. Not everybody, maybe, or not in every context. For example, if you want to do async on WASM, you can't do multi-threading because there's no threads. You cannot do green threads because you don't have stack switching on WebAssembly today. There's a proposal for it, but it's not part of the standard yet. So if you want async in WebAssembly, you need to do stackless today. So that will be a situation where you will need to switch to stackless no matter what. But that's the idea. Yeah, sorry, I dropped one thing. Let me go find it. Okay. Thank you for clarifying and explaining. I know the Zig way is to have same defaults and give options in the standard library, but still wanted to confirm. Glad we are heading in that direction. Yes. Well, the main goal of the standard library is to define the IO interface. That is the critical part, because everybody will conform to the IO interface. And so, depending on how good that interface is, that puts a limit on how good implementations can be, in a sense. There's already third-party implementations. For example, there's this. Here. On Zigit, there is a thread. Alternative STDIO implementation in ZIO. So this person, Lalinsky, has made their own implementation of. Well, they have their own event loop called ZIO, ZIO, and so now it has it now fulfills the std.io interface, and so you can use this implementation if you want. I think this one is a green thread implementation. So yeah. Okay. Uh, so for permissions, I think that what we can do is, so as I was saying, maybe we make a global array. You know what? I think maybe for the future we can make something more sophisticated. But for now, global array is not bad. Hmm. How big is one of those rate limiters? Uh. Mm, 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 mm. Oof. You know how we could change this? So in theory, we could make this generic and it would work. But here's how you make a ton of these guys and you make them cheaper. You take, well, first of all, you take this out because you should be able to pass IO to this guy. And then these two guys you pass in. Or rather, you know what? All these three guys, you pass these guys in. So wait, not all this, not the timestamp. I think the timestamp it needs to be stored, but you this guy and capacity. So you pass down. I think these guys you basically write down as a like config strat, and then you pass that to take token. That way, this guy becomes a float number which we could probably turn into a 32-bit number. I think that probably the float stuff is gonna be fine. Timestamp is a I-96. Jesus Christ. Okay. I think even that we could change. I think those are too many bits. It's unnecessary. Um I think we could reduce the sizes of all these things. Let's fix this interface and let's make some configs. So pubconst config. It's a struct. Config has capacity. Let's start. I think we can turn everything F32. Why not? Make them smaller. F32 refill rate per second. F32. So now when you do init, you pass in the config. And actually, you just need the capacity. But for simplicity, we do everything off of a config. So these guys are gone. And take token takes a config. and also an IO. Okay, so IO clock real now, IO. Last refill timestamp, elapsed seconds. Refill rate per second, that's from the CFG. CFG capacity, blah, blah, blah. Okay, check this out. And we can make standard configs even. We can even make standard configs. So for example, pub const connect is going to be capacity. What is it we did? I think capacity 5 refill rate per second equals 0.2. And then we have TCP message. TCP message, I think was 5M1, something like this. So, oh man, this is gonna be so good. Let's see. Hi, Loris. I've been trying to set up a command to do the file watch and do no binary linking. Okay, and have instant compile time errors, but I don't seem to get it working. Is there documentation about it? So to get watch, all you have to do is zig build -- watch. This is it. Nothing else you have to do. Just -- watch for watching. Then you want to avoid generating an executable. Here's how it works today. In your build script, you need to create a check step. I think my check step here has regressed. Like this check step in this build script is broken because I changed some stuff and I didn't fix it back. But here's the key point, okay? Oh, and obviously, if you want your stuff to be instant and you have a check step, you need to do zig build check and then -- watch. Again, in my case, check. I don't know if check works. I think I broke my check. It's stupid, but that's of me. Let me pull up another project. I think Zine has that. Oops. Yeah. Okay. So here's the key parts. Oh shit! And I'm not doing it. Okay, I'm a doofus. I'm not doing it well here. For the check step to not trigger binary linking, the executable that your check step depends on cannot be mentioned in b.install artifact. So if this executable is a b.install artifact executable, then the check step will still generate the executable. So you need to not have this. Obviously, you will still want to install your executable sometimes. So you need to basically define your exe twice. You literally need to have a definition of your executable where you define exe like 1 and then exe 2, or more precisely, you probably want to define exe like vanilla and then exe check. They will have to share everything else. So you can even make a function to like produce executable definitions. But then in check depends on zine exe check, not the other one. Because the moment an executable is mentioned in here, then internal state in the executable is flipped, and that executable will trigger binary linking. In my case, the reason why this is not set up is because um, I didn't care in this case. Also, because I usually use architectures that don't have full instant incremental compilation yet. Sorry. Well, no, I mean, what I'm saying is dumb. I could do that because the whole point is to exclude backends. So I don't know. I just didn't care, I guess. It seems. If you want a written version of what I just described, there is this. Um, there we go. Good luck. Okay, so we have connect TCP message. Okay, so now we can turn this stuff into CFGs, and this can be dot connect, and down here there's another one, TCP message, and we use this guy. Dot. That's enough to get instant compile errors. It should, yes. I tried wrapping my B install artifact in a b.option bool. No, that does not work. That does not work because let me think about it for a second. Uh, actually, I think that should work. Yeah, I think that should work. So that means that if you specify d no bin, then you do zig build check d no bin watch, then it should work. Well, okay, let me put it this way. If you have this stuff online, share a link to the repository and I'll take a look if you want. I think that this should work. You could try to be more defensive and just make the copy of the executable as I said. So if the copy works, then it means that either this approach is not enough, but that doesn't sound right to me, or more likely, you have something else. You have somewhere else something that forces um, compilation of your, well, linking of your executable, and you just didn't notice. So, or I don't know, some bug in the build system, but that doesn't seem right to me. So what I would say is try with a clean executable approach. That way it's easier to not make mistakes. And then if that works for you, then it's likely that you have something that triggers this stuff and you didn't notice. That's my theory. Okay. Next thing that we want to do is well, Zig build so that it works. Oh, but we're already doing it, so it does work. The next thing that we want to do is do the global array thing, global array listing. Yeah. Use user.id to index into the array. Yeah. User limits. I think the algorithm that Rocco Rager proposed is interesting. Instead of a bucket with bursts, uh, the problem is that there is a variety of these things. Like you have, um, for example, you have writing notifications. So the idea that you send a notification that you are typing into a channel, like you're replying to a channel, there is a message that you keep sending because we could say that the message is supposed to last like a couple of seconds, so you send one every 2 seconds in theory, and that is a thing that you do every 2 seconds. It should be tracked like everything else. Where do you find an F64? Oh, so user limits. Now, where do we look at those user limits? I guess it has to be in TCP read. Depending on the market that we see, well, technically, we would like to um, have these things have different costs, and our implementation currently doesn't support that. but it would be nice. Okay, so let's say that you want to join a call. Then, well, in here we lock state, right? We deserialize the message, we lock state, and this is where we should look um, into your rate limits. Items. How do we know the user ID? It's in client. Is it authenticated that contains the user ID? Yeah. Take token. What's our CFG? Um, for now, we can make just dot user. User action. 3 actions per second. That's it. If you're typing, you're not sending messages, fine. 4 per second. Nah, fuck it. 3 per second. Yeah, I think these callbacks should be called probably with the message already deserialized and the state already locked. And we do this up top. Maybe. I don't know. In any case, log dot debug. And so this should make us send the client a uh, message that says that they're being rate limited and that the request didn't go through. Yeah. Request specific error code, but this one that we want to put is not request specific. This one is like it's permissions based. How do we do this? Maybe this shouldn't be an error case. This should be rate limit. And there should also be permission. Call join doesn't have origin. Wait, what? Really? Well, fuck, that is a problem. This origin thing should be kind of a global, probably. Why is this namespace so much? Oh, it's for us, no members. Oh, this is why. Okay. So with this, we have the concept of failing because of rate limiting. This seems good to me. Oh, I'm looking at YouTube chat right now. Yeah, so the Bork is probably borked. Let's see. The command I tried is zig build dino bean watch f incremental f prominent compile errors. That makes sense, but where is your check? Oh, because you want to do this on the default step. No, you can't. Okay. K um KK. If you're still around, uh make a check step and then make your check step depend on the executable. Your f incremental, I think it's not. No, it is necessary. You're right. You do need f incremental, I think. Actually, do you? Well, I think you can put it there. But yeah, no, I think it's right. But what is missing in your command is the fact that you need to run the check step. You need to make a dedicated step because the default step will attempt to run the install step. And if the install step doesn't depend on anything, because in your case you're removing the call to bead on install artifact by putting it behind logic, behind branching. So what you want uh is just to define a check step. So everything else is fine. Define a check step, make it depend on the executable, and do zig build check and then everything else, and you will be good. I'll try to restart Bork, but I don't know if this is me or YouTube or what. Okay, I can tell you that YouTube doesn't like me anymore because I don't even see. Yeah, look at this. Reset. Stupid YouTube, man. Nah, never mind. No, YouTube is still broken. Otherwise, I would see old messages in here. Sorry, I've gotten rate limited by Google. Google hates me. Doom. Okay, so these are the beginnings of rate limiting. I think we can try this out. Let's wire these to sending messages and let's see what happens. So in send message request, actually, this thing is self contained enough, basically. Okay. So, we need one last thing. We need to initialize these bad boys at program start. And in theory, we need to increase this when signing up a new user, but we currently don't have support for that at all. So that's fine. Okay, let's go into load state, maybe. Fuck. Oh no. Oh no. Is it this one? Bro. I think it's this one. Okay. So load state, settings, chats, voices, last messages. We wanted the users count. Is it select count star from users? No, they're not copies. They were mentioned in the past, and Flow is remembering them, even though the files don't exist. I think that is a piece of behavior that Neuroside should take a look at some point. I think it does in my case. Like this guy doesn't exist. Uh oh, it does exist. Uh oh. Never mind. I have a bajillion files that make no sense. That's on me. There's another one. User database. But now I'm curious. Okay, what if I do this? I go in here and this is importing dot dot database. Okay, what if I do this? Const db2 equals add import database dot zig. I save this. Okay, let me fix this and use local constant. Okay. Now I have file not found. I go to definition. This brings me to the file that does not exist under server user database. I close. There is no database. Okay, then I save those files by mistake. If it has to be. No, or rather, yes, there is an issue, but it's me. It's the me part of the workflow, I suspect. Uh, well, never mind. So far, so good. Okay, so user count, and then they want to do state dot user limits equals mm, what is a thing? Wait, what do we do to? It's not an equal sign. What do we do to add a bunch of elements all at once to the array list, and then we want to zero them afterwards? Insert. No. Add many at. No. Or maybe yes. Maybe this is it. Add many at. Add count new elements. Add position index, which can be zero. Yeah. Honestly, I would be happy also with an add many without at, but that doesn't seem to be the variant. So Okay. Hmm. So we have this. I think that's it. I think now I can send a few messages and see the thing complain. Fuck. Here we go. User zero exceeded user action limit. This last message was never acknowledged, so it stays gray. And in the client, no, we don't have. In the client here, we have unknown server marker message. There's a message that we're not handling, which is the rejection. Okay, that's kind of it. That is kind of it. I mean, obviously, we need to have the part where we acknowledge the fact that the message was rate limited and failed to send, and so there should be a thing where you're even like allowed to retry or something. So obviously the part is missing, but the basics for rate limiting are there, which I think is good. Also, holy shit, it does take some effort to hit that even very low limit that I currently have. It does take some effort to get there. So what can I say? I don't know. I'm happy. This was productive from my perspective. We have the beginnings of rate limiting both at the IP level. I do want to know if um yeah, I do wonder if fail to ban is the right way, or if the right way is to have some more like management of this stuff. I don't know. Also, because for the fail to ban, like you need a policy. Like how long do you fail to ban an IP for these kind of things? Like I feel like that the correct behavior requires more nuance. I don't know. Well, in any case, we have some of the basics. This is all pretty cool shit. And yeah, I think I'm gonna stop here. So for the people, fail to ban is probably not worth it. What do you mean? You mean using fail to ban, as in you think we should try to use the firewall directly? You can do the same thing in the process. Uh, well, I mean, isn't using an OS level firewall going to be preferable? Also, I would imagine that if somebody has an even more sophisticated setup, I'm guessing they could wire fail to ban. Is really only needed for DDoS protection, which I get. But I mean, there is a possibility, right, that you start getting DDoS on your server, and you would like to, I don't know, survive that if possible. Well, in any case, so for the people watching who don't watch normally, since there's way more people than usual, I don't know. Follow the stream if you want to be notified the next time I go live or something like that. We're gonna do Zig stuff in here, like we always do. Or if you're interested in following along the standalone Discord alternative that we're working on, you want it. I mean, look at how sexy it is. Does it not make you want to use it? Yeah, it does not make you want to use it. I know, but still. Anyway, I don't see anybody doing Zig. That is sad, but I will raid somebody since there's so many people. I'll be nice. I'll be good. Building Space Drive 2, a next gen file manager in Rust. Linux kernel dev builds RISC V desktop. That is interesting. I think I will send you to T2SD. So enjoy some RISC V development.